Great Britain today, there are about 4,000 traffic signals, and over 100 million vehicle hours each year are spent queuing at these signals. Much of this delay cannot be avoided with single-level intersections, but of course every effort should be made to reduce it. As part of an investigation into this problem, the Road Research Laboratory has been studying the maximum amount of traffic which can pass through signals under various conditions. Knowledge of this kind is useful, not only in setting signals, but also in predicting the savings which would result from widening the approaches to junctions or from prohibiting parked vehicles and right-hand turns. Many observations have been made at actual intersections to find the effect of turning movements, traffic composition, and junction layout on the amount of traffic which can pass through an intersection. Observers using special recording apparatus counted the number of vehicles passing through in each second of the green time. Investigations at actual intersections are limited by the range of road widths and traffic compositions available. Such observations are also affected by many irrelevant factors. To get over some of these difficulties, an experiment was designed so that the variables could be largely controlled and a wide range of conditions could be studied. This controlled experiment was carried out at the Fighting Vehicles Research and Development Establishment of the Ministry of Supply, using part of their test track. This is the layout of the test tracks which were used. The first part of the experiment was concerned with the effect of road width on the number of vehicles per second of green time which could pass through the signals. This was carried out alternately on circuits 1 and 2. Whilst the traffic was using one circuit, the approach road width of the junction on the other circuit was changed. By this means, many different approach road widths were investigated. Here, traffic is seen passing through one of the narrower junctions. The width studied on this circuit varied from 10 to 30 feet in small steps. Observers recorded the flow of traffic onto punched paper tape. The recording and analysis were made easier and more reliable using this machine. The investigations here dealt with wider junctions of the Hyde Park Corner type. Because the road straight ahead was not wide enough for all the traffic, some of the drivers turned left or right, whichever was most convenient. Between tests, the road width was altered and approach widths of 40, 50, and 60 feet were studied. The way the maximum possible flow depends on the road width was found from these experiments. The maximum flow per second of green time is roughly proportional to the approach road width. It is about a quarter higher than the corresponding value observed under actual conditions in London, probably because there were no cyclists, pedestrians, or turning traffic in the experiment. Both curves show a similar shape, and it is reasonable to assume that the London curve would follow the same trend as was found in the controlled experiment. So we may predict with some confidence what the capacities of very large intersections would be. To investigate the effect of goods vehicles, two circuits were used simultaneously, and intersections with approach widths of 18 and 24 feet were marked out at A and E. The experiment began with all the medium and heavy goods vehicles using this circuit, and all the private and light vehicles this one. Gradually, throughout the test, the composition of traffic on both circuits was altered by interchanging vehicles from one to the other. Every few minutes, 2 or 3 light vehicles were fed from this circuit and taken to the other one. At the same time, a few heavy vehicles were taken from this circuit to the other one. The traffic is now a fairly mixed composition. By this method, it was possible to study a whole range of compositions between 0 and 100% of goods vehicles at each junction. The results of this experiment show that the number of vehicles passing through the junction per second falls off as the proportion of goods vehicles increases, and these results are valid up to 100% of goods vehicles. Broadly speaking, one medium or heavy vehicle is equivalent to about 1 3/4 private cars. The relative effect of goods vehicles found in this experiment is almost exactly the same as is found on the road, as shown by these points, in spite of the fact that conditions were artificial in this experiment and there were no pedestrians, cyclists, or turning traffic. If we now look at an actual intersection in London, we can see turning traffic and cyclists affecting the capacity, but eliminating these factors, as we have done in the controlled experiment, has not changed the relative effects of the remaining variables. This makes the controlled experiment a very powerful tool for studying traffic problems. Another factor which affects capacity is the presence of a parked vehicle on the approach to an intersection. This parked car is causing difficulty to vehicles in the queue. Parked vehicles reduce the capacity of junctions, and this factor was investigated in the controlled experiment. The test was carried out on this circuit, where 3 intersections of different widths were used, at C, D, and E. This is a 24-foot carriageway divided into 2 12-foot lanes, one in each direction. Here there was opposing traffic in order to make conditions realistic. At the other sites, the approach roads were 24 feet and 18 feet wide, and there was no opposing traffic. This is one of the wider junctions. No parked vehicle is present at the moment, and 3 lanes are in full use. Here, a vehicle is parked 80 feet from the stop line. The flow is reduced to 2 lanes towards the end of the green period. The effect of a parked vehicle is equivalent to a reduction in road width. This graph shows that the effect of a parked vehicle decreases as the vehicle is parked further away from the stop line. For example, if a vehicle parks at the stop line, the effect will be the same as if the road were some 5 or 6 feet narrower. If the vehicle now parks 100 feet away from the stop line, the effect will be the same, according to the graph we have just seen, as if the road was 2.5 feet narrower. Coming back to the original graph, We can see how these results compare with those obtained in London, as shown by these points. Again, the agreement is good. A parked vehicle on a congested road may be wasting valuable road space. The total delay caused to other road users may often be much more than the time the vehicle stays parked, and the effect may last a long time after it has left. We have now seen how three of the main factors affecting the capacity of intersections controlled by traffic signals have been investigated. The results obtained from this controlled experiment have confirmed and extended the results obtained under actual road conditions. This information has been used in the setting of traffic signals to give the least delay to all vehicles and in predicting what effect changes in road layout and traffic control will have on the delays to vehicles and on the capacity of intersections.